Okay. In this clip, I'm going to talk about the chi-square probability distribution, which I have placed on Blackboard as a PDF. I went ahead and copied it from the book. Oops. I copied it from the book, but I also, let me see. Yeah, I present that there's really two. Wow, only one's necessary, but I copied it from the book at the normal size, and then I also expanded it. I made it larger than it appears in the book. So if you want, either pause this video and or make sure that you have access to the paper copy that I have placed on, or the PDF file that I placed on Blackboard, or take your Spatz book in the 8th edition and turn to page 389. And this clip, we're going to talk about how to choose the correct chi-square value. You may recall, let's start there. I'm going to discuss a couple of things about this table. First, you'll see that whether you're looking at your book or whether you're looking at this table, you'll see that you have a shaded portion right here along the left-hand side of the table and across the top, the shaded portion. We'll get to that in a little bit, very shortly. But the first thing I want to point out at this point is not the shaded portion, but rather the middle portion, these numbers that are in the middle, the background is white. 2.71 in the upper left-hand corner and 59.70 in the lower right-hand corner. All these numbers in the middle, what I'll call the middle of the table, all these numbers represent units of difference. Specifically, they represent units of difference between a concept that we haven't dealt with but that I referred to earlier, units of difference between observed frequencies and expected frequencies. So for now, all you need to know is that these numbers in the middle represent units of difference between observed and expected frequencies. Specifically, however, since we're looking at a probability distribution, those numbers represent, and this is really important language, represent the maximum amount of difference we could expect to observe by chance given certain conditions. Let me repeat that again because it's so important. These numbers in the middle represent the maximum amount of difference we could expect to observe by chance given certain conditions. Last time, for now, these numbers represent the maximum amount of difference that we could expect to occur by chance given certain conditions. What are those conditions? Well, those conditions are what appears in the shaded portion of the table. Those conditions are degrees of freedom and the size of your tail, or the critical region, or the rejection region, or the alpha region. All those terms are used interchangeably. The maximum amount of difference we could expect to occur by chance given certain conditions. The degrees of freedom and the size of the critical region. So, degrees of freedom we've already discussed, or at least dealt with. You've dealt with the calculation of degrees of freedom. The first row is when the degree you would use when the degrees of freedom are 1. So for example, that first contingency table, 2 by 2, remember? Row minus 1 times column minus 1, 2 minus 1 times 2 minus 1, or 1 times 1, which is 1. So for a 2 by 2 contingency table, or more specifically, when degrees of freedom are 1, your tabled chi-square value is going to come from that top row. If your degrees of freedom are 2, your tabled chi-square value will come from the second row. If your degrees of freedom for your chi-square analysis is 3, it would come from the 3. So in other words, the degrees of freedom, and again, hopefully you understand how to find the degrees of freedom if you were given a contingency table. The degrees of freedom will dictate which row your tabled chi-square value will come from. Again, degrees of freedom found here, 1, 2, 3, 4, 5, 6, 7, 8, all the way up to 30. Your degrees of freedom will dictate which row your tabled chi-square value will come from. The degrees of freedom will dictate which row your tabled chi-square value will come from. The size of your critical region, also known as the alpha region, also known as the rejection region, the size of your critical region will dictate the column from which your tabled chi-square value will come. And as you can see, looking across the top, you have several options, several sizes of critical region or alpha region to choose from, starting with 0.10 on the far left column and ending with 0.001, a very small critical region, rejection region, alpha region on the right. So if you may recall that when you were conducting F tests and working with the F probability distribution table, that you only had two options, two levels at which you could conduct a test. Do you remember? 0.05 and 0.01. When you were looking at the F table, if you were asked to conduct the test of the hypothesis at the 0.05 level, you would use the light-faced text. If you were asked to conduct the test at the 0.01 level, you would use the bold-faced test. Well, when you're conducting chi-square analysis, you're also limited, but not as limited, because as you can see, there are 1, 2, 3, 4, 5 columns present on the table. That means you have five levels of rigor, 5 levels at which you can conduct a test, and those levels are 0.10, so the size of the tail, the size of the critical region, the size of the rejection region, the size of the alpha region is 0.10. You could also conduct the test at 0.05, you could conduct the test at 0.02, you could conduct the test at 0.01, or you could conduct the test at 0.001. All I was doing was just reading the sizes of these alpha levels, and in fact you can kind of see it up there, alpha level. Reading the size of these alpha levels, critical region sizes, rejection region sizes, tail size in the tail. So in sum, these values inside the table represent tabled chi-square values. They are the maximum. They are the maximum amount of difference we could expect to occur by chance alone, sampling error alone, given certain conditions. And what are those conditions? Degrees of freedom, which you know how to calculate, and the rigor of your test, meaning the size of your alpha region, the size of your critical region. Okay? So if my degrees of freedom is 6, play along with me. If my degrees of freedom is 6, and I was asked to conduct the test at the 0.05 level, my tabled chi-square value would be 12.59. 6 degrees of freedom, 0.05 level. If my degrees of freedom was 15, and I was asked to conduct the test of the hypothesis at the 0.01 level, so 15 degrees of freedom, 0.01 level, my chi-square value would be 30.58. So that's the maximum amount of difference I could expect to occur given 15 degrees of freedom and a critical region of 0.01. If my degrees of freedom are 5, and I was asked to conduct the test of the hypothesis at the 0.02 level, my chi-square value would be, my tabled chi-square value would be 13.39. 5 degrees of freedom, 0.02 level, 13.39. So that's just a few examples of how to go about choosing the correct tabled chi-square value.